Hi, everyone. Um, Welcome to another episode of the Common Lisp Study Group. I'm your host, Ram Vadam with Atlanta Functional Programming. For the last few weeks, we have been, just to get folks up to speed, exploring how to leverage graph databases with the cl-neo4j library. The cl-neo4j library was a library that was originally written against the Neo4j 3.5 HTTP API. It was a lisp-ier way for you to interact with the Neo4j graph database through the HTTP API to be able to query and insert and retrieve nodes, much like any other graph database in a lisp-ier fashion. However, we extended it last week with at least the start of what we would consider to be um, a an approach to actually leverage a newer HTTP API that was introduced as part of Neo4j 4.x. The version currently is in the 5x series. This includes particularly the ability to do transactions because as part of the Neo4j 4x series, they actually became ACID compliant. So you can now do transactions using the proper atomic acid properties that you would normally experience with other databases, particularly relational databases. Most people are familiar with using ACID transactions. Some graph databases recently also started adding same sort of capabilities. Um, Today, I thought we would take a step back and start talking about Neo4j in general in terms of uh, how to actually write queries against CYPHER and sort of then grab um, the ability to, what's it, define the abstractions to be able to interact with the new Neo4j API in the same way that we would do with the old HTTP API. And more importantly, it allows us to at least figure out, what sort of things would we want to actually expose in this new library. Finally, time remaining, we'd be able to discuss some sort of front end stuff. Uh, but we'll see how far we get because sometimes these discussion takes longer than expected. As usual, before I begin, I just want to mention Atlanta Functional Programming is in search for speakers. So for those of you who are interested in providing a topic that's functional related, either promoting functional programming in your language of choice or a particular library that adopted a functional style for composition and so forth, feel free to drop me a line. I'm Bugram on Functional Programming Slack, as well as I actually squat in the Lisp Discord server as Bugram as well. Uh, you can interact with me in either of those places, and I will more than happy schedule you in our talk list. Additionally, for those of you who are in and reside in the Atlanta area, Atlanta Functional Programming is looking for a new home for our in-person meetups. Again, if you have any ideas, suggestions, feel free to drop me a line in those same avenues. As um, and one more thing for those of you who are our YouTube subscribers and watching this on our live channel, feel free to like the video and subscribe to our channel for new updates, new videos, and so forth. Um, as we do more of these, we tend to do weekly episodes of the Common Lisp Study Group, but some more talks may come along the way as time goes on. So to begin with, I thought I would first, um, one second, I'm having some issues. Here we go. Good. I thought I would first, okay, one question from one of our patrons. The Lisp Discord server I will post um, on So there's a question on the Lisp Discord server. If you go to lisplang.org slash community, sorry, for folks who are watching on YouTube, as well as uh, the folks who are in the midst at the Jitsi meeting. There is a link to the Lisp Discord server to look into there. Additionally, for functional programming Slack, there is a way to get into the Slack community. It is in the to join the channel. It's in the GitHub repository. Sorry for the actual community itself, fpslack.com. But I will go ahead and post that too as well. All right. So last time, and I think the easiest way to first begin here is to first switch up to our actual Neo4j window for a second. We actually went ahead and inserted a bunch of nodes inside of the um, uh, graph database for a particular type of movie. Specifically, I created a Matrix movie, a movie that gave some basic details for like the Matrix. And we actually saw that by running a match query for this particular uh, query node. Now, I mentioned this last time that each node is itself a very unique node that contains an ID along with the particular metadata. All right. Um, in Neo4j, just like any other NoSQL database in which graph databases fall under the NoSQL database, um, the nodes themselves are going to be considered unique. The metadata information in there, the constraints on them doesn't cause the uniqueness. Now, this is very different from folks who are familiar with the relational model, where you can define the primary key for your particular database based on one or more fields. All right. Um, as far as I know, there isn't any particular way for you to provide this other than maybe providing a unique constraint inside of your graph databases for your particular graph. But even there, I'm not entirely sure, at least with respect to Neo4j, if that's really technically possible, and if, more importantly, if that's actually best practice when you're doing modeling inside a graph. Okay. So there's a particular approach to actually wanting to define your graph. And it's this flexibility to being able to provide maybe some sort of commonality that allows you to um, create more complex relationships and more complex models uh, in a much more flexible manner versus what you would normally have to do in a relational model to prevent, in most cases, um, heavy duplicates of information, some redundant information, by actually normalizing your database and then making sure that you're going through and referencing particular unique values through maybe foreign key constraints to another another database, another table, or even another database's relations. Um, versus in this case, you might want to actually add that as probably like a unique index when you're actually modeling inside of the graph. Okay. Um, there are some details on modeling inside the a graph that makes it easy for you to actually um, be able to uh, uh, create stuff inside of um, uh, Neo4j. And I thought I would take a moment and at least show you some of this stuff before we go back to our Lisp REPL and see how we might actually add some of these nodes, and maybe even add a couple more functions for defining relationships. So let's go ahead and for the first time part of this, let's clear our database, because this is kind of a scratch database. I'm going to remove all the nodes that you're seeing here, just so that we can actually start with sort of like a clean slate. Um, and let's get all the movies out, and let's do delete A. Okay, so now all of these nodes are removed. We could see this by just simply rerunning this query, and you could see that there's no records. So let's go ahead and recreate, just for the sake of example here, in Neo4j directly our particular movie node that we want to start with. Let's just say again we have we're going to start with just the matrix. We're going to model the matrix movie. All right, so this means a movie contains actors are uh, we know who the directors are of this movie, when it was released, and so forth. So we're going to add this has relations here, and then we're going to write a Lisp function on the side to get this information, because we've already created one of the functions to create these nodes. But additionally, we want to be able to maybe even add a couple of functions to add relationships for the property graph, as well as being able to do this inside of a single transaction. Okay, so to start with, to show you guys some of this stuff, I thought it would be important for us to first know what the CYPHER syntax is, because I'm assuming for folks joining in who've never touched you've never touched Neo4j, you're not familiar with kind of what CYPHER is, and uh, you're not entirely familiar with how to interact with Neo4j through CYPHER or even through any sort of graph language. Okay, so the stuff that I showed you before with creation is only one aspect of this. So one is just, we could create a node, which we've done with uh, the create syntax. We said the matrix movie, and we created title the matrix, and we created this release date 1998, I believe it was, or was 99. It was 99. Okay, all right. Okay, so 1999. Okay, we go ahead and we add this guy back in. So we can now say, let's create, Keanu Reeves actor, person. Yeah, okay. And then in our metadata, we'll say his name is Keanu Reeves, and let's say he is occupation actor. Obviously, some folks might end up making actor is a person, um, and have an ontological sort of relationship. But for the time being, I'm going to go and use this as metadata and to show you some of the nice things you could do with Neo4j and the creative. What is it? The use the what's it? The CYPHER language to actually go ahead and run those queries on top of the actual metadata itself, versus what you could probably do with, like, say, Sparkle, and other graph query languages, where you end up modeling these relationships a little bit more rigidly. So I'm going to go ahead and create these two nodes here through this. Let me then switch over to our Lisp REPL. And we're going to go ahead and add um, a couple of more queer functions here for defining relationships, okay, in our library. And then we're going to use that to actually go and create our relationships here. Um, what is a relationship? A relationship is just inside of Neo4j is the property graph. So it's basically an edge that contains a title that represents that edge. It's a labeled edge, but that labeled edge can contain additional metadata. Um, so, for example, if you want to model graphs with weights, okay, so maybe you're trying to do pathfinding inside of, say, an AI engine. You could use a graph to actually have the weights on it inside Neo4j, and then use CYPHER to go ahead and implement shortest path for you. There's actually functionality, I think, built-in functions inside Neo4j to actually do this already. Um, but stuff that I haven't actually experimented with, to be honest, for weighted graphs. But for folks who want to model that, there is that stuff, and the way you do it is this approach of being able to take a model, a edge, which represents a relationship, and add additional metadata on top of that. So let's go ahead and add tx create relationship, and what we'll do is let me go ahead and close that. Let me split this. Let's make sure that I'm modeling this the same way that and then let's go ahead and add by ID and delete. Although get by ID may not necessarily make sense in our new API just because of what we're leveraging. But you know, we could create all these types of lisp-ier functions to actually get some metadata based on what we want to do. Okay, so hold on. Is there? Okay. And for each, for folks who are looking at, who want, who have questions on Neo4j or CYPHER, feel free to post them in the chat, as well as in whether you're on the Jitsi meetup or you're in the live stream, and I will answer them accordingly as we go through. I just wanted to cover both the Lisp side of this stuff as well as the CYPHER at the same time. So I'm going to be switching back and forth. So if there's any sort of confusion, stop me, and I will go ahead and clarify those questions as we go along. All right. All right. So in fact, let me do one thing. Let's switch back to one other thing that so that we can actually see what we're going to be modeling inside of uh, Lisp, or we're going to design, and that is in Neo4j. We created these two. We created these two nodes. Okay. Now we need to create a relationship to these two nodes. Okay. And the way to do that is you have to attach a relationship inside um, uh, your CYPHER query, okay? And uh, and that's through a create as well. But let us let me just pull up something here. Getting started with there. Okay. Now we created that. Um, Okay, so once we have these two nodes, if I remember correctly, actually, hold on 1 second. I have to pull up my notes on one thing here. Okay, so what we need to do is create now one more thing in here, which is, that's right. So now that we have these two nodes, we could say create Keanu Reeves person, sorry, Keanu Reeves person acted in, and then we do the matrix, okay? And we don't even have to say person. We could just say Keanu. You see, the nice thing about this is CYPHER allows you to write this in a syntactical way. And what this is this takes the node that we created. This here, I guess I should explain what this syntax here is. When you're creating nodes inside of Neo4j, each node has a metadata that's considered to be a unique name that you could provide. Okay, so in this case, Keanu Reeves is our node. And it looks like I just may have created a blank thing. Hold on 1 second. I may have to delete Keanu. Hold on. This acted in is wrong. Hold on. Match a because of delete a. You must delete its relationships. Okay. Let's first delete the relationships between this. Okay. And now we need to see if we have A equals Keanu. Did I spell it wrong? Yeah, Keanu Reeves. Delete. Oh, Keanu Reeves, because I spelled his name wrong in the first time of creating him. So let me go ahead and do that. Delete. Let's see if I could do that. Oh, wait. Let me go ahead and do this. Just cleaning it up so that we have some proper name representations here. Okay, so let me go ahead and edit this. Run this guy again. Okay, now let's do this. Match a person, return a. Let's make sure that we have only, oh, we have two of them. Okay, so let us do this. Match a person, delete a, and then we need to start over. 1 second. There we go. Let's do this again. Create our node. Oops, sorry, wrong thing. Not equals. I meant that. Okay. Do another match to make sure that there's only one person in here for now. Okay, so we have that. Now we can actually go ahead and recreate this, and I can explain this. Okay, so to create okay, acted in the matrix. So let's check out the relationships. So let's run a match query. A, C, B, return A, B, C. Okay. So we know that there's at least one relationship here. But what we want is more information than just this. So what this database, what nodes are, is each of these nodes is a unique node inside of the database, okay, that contains an ID. You can reference them directly by the label that you provided for the node, okay? You can reference it generically by using a variable when you're using a match query, all right? Or you can also run, a match query with some constraints, as you saw earlier that I was doing. Okay. So a node that was created with this reference, okay, that you provided, this unique name that you've provided, okay, can then be leveraged in order to add more relationships against that same node. Okay. Inside CYPHER, creation of either nodes and relationships can be done all at once, and we'll see an example of that when we go into Common Lisp. Or you could do what I done is add the nodes all up front, and then add the relationships as a second pass. Okay, once you've actually provided the nodes. Okay, so there's a question here. Node IDs need to be unique. So is there some layer that manages that uniqueness? Yes. So node IDs internally are unique. So a node object contains an ID that is created by by cl-neo4j when the node is actually inserted into the database. So that node object instance is unique from the aspect of neo4j. Okay, but the node metadata, that is the data that's associated with that node, doesn't necessarily need to be unique. If you want to add the metadata unique constraint, that's a unique constraint, and we'll have to add the ability to add those unique constraints later on. But nodes in general, relationships in general, are all unique nodes as far as Neo4j is concerned. Okay, you could consider them essentially nothing more than a a table with it's basically an insert every time you insert into a relational database. That's the easiest analogy that I could come up with. So when you're just doing a random insert into the database, but you're not looking at the actual metadata to make sure that the columns inside of the database are unique relations, it's just that node ID is always going to be unique. Yes. The question is, there's a question about, would it be possible to have two nodes that have the same metadata but different node IDs? Yes, that is correct. You can have two nodes with the same metadata but different node IDs, and we saw that earlier when you may have noticed that I was able to insert the node with the same matrix information multiple times inside of the graph database. So now this here that we see isn't giving us much information. So let's try and adjust this match query a little bit, okay? Let's see, um, A, given A person, C, B, movie, return A and B. What can we do here? So this is not giving us all the information that we want. It looks like we are missing one relationship here. Let us look at something here. Okay, so let us do match a person. Let's say name Keanu Reeves, acted in a movie. No changes in the thing. So that means this node here that was created, this relationship here is not correct. So I would have to actually add additional things here. Okay. Let us do this. Let's remove that relationship because I must have done not return C, delete C. And let's go back to this guy and let's do an explicit person, and let's add movie here and see what happens. Okay, so created two labels, created two nodes, and created one relationship. So this is not actually. So here, let's see what happens when I do that. There is a create query that I'm creating that is not actually adding stuff the way I expect it to, but we'll see why. Oh, I see now. Okay. I made one mistake in my relationship, folks, and that is because of the fact that I am creating I need to explicitly say that it needs to look for that node, because otherwise it's going to think each node is unique and it's going to create blank nodes inside of the database. So let me start from scratch for a second here. Not sorry. Match A, delete A. Let me just quickly do this. We're just going back for a few steps. Let me run this guy. run this guy, and let's go ahead and do match A, return A to make sure there are only 2 nodes. Okay, so now we have this information. We know that there is information regarding neo4j. I mean, sorry. We have information regarding the person and the nodes. We just need to create now this thing, which is create a acted in B. And this is the way you do it after the fact, which is why I'm doing this, where a dot do this. A person, let's be very explicit about this. B movie, okay, and where a dot name equals Keanu Reeves, and b dot title equals the matrix. New syntax error. Hold on 1 second. Where expected. Let me try one thing here. Let's see. Let me do this. Let me write a match create query. A person, B movie. Let me see if I could do in this case both are single node. None of these matter. Okay, hold on. Let me see if there's I'm missing something in the documentation. Just give me just 1 second here. It's been a while since I've done this. That's right. I have to say start. I have to write a start query for this. Start A equals node Keanu actually let's see this. A equals start. Let me expand this for a second here. Start create let's say A equals node Keanu match a person where a dot name equals Keanu Reeves. B equals node match B dot movie where B dot title equals the matrix. Now we could create, hold on. Oops. Expected database. Hold on 1 second. Let's see something here. Maybe I'm doing something wrong here. In the modeling, got it. Okay, so the way we have to do this is with the merge query. I forgot about this. I have to do this. Match a person name create. Well, it doesn't matter. Keanu Reeves. Match B movie title the matrix. Now I can do merge A acted in let's say C acted in well, I'll just say C acted in. Let's see what happens here if I do it this way. And B return A C B. And there's an error here. Expected. Oh, sorry. Once again, I used equals. So used to using equals. It should be this. There we go. And now if we look at the graph, we now have our acted in things. So this is something that we need to interact with and understand in order for us to actually create relationships for existing nodes. Now, if you did this all up front, you could have easily done, you know, this in a single create query, okay? But this is kind of the nuance of Cypher that you have to kind of get and understand, which is like, and obviously if you don't do it every day, sometimes it's pretty easy to forget on the querying. But the idea is basically um, creation can happen all up front. So you could create all your nodes and relationships in a single query. But if there are existing queries, you're essentially doing an update at that point, right? You're updating that existing node's metadata with additional information. So like what edges are it's connected to. And you could see this when you look at the table that gets created here, all right? We have this node, we have this as acted, okay? This new relationship that was created acted in is now taking the start index, all right, which is for our person index, and our end index, which is 1, is our movie, and it attaches this information to it so that these two can all be connected inside these 3 databases, okay? But that's just kind of what some of this interaction stuff you'll see as we continue to model this and appropriately put this inside our common Lisp library. Okay. Are there questions about this? This is just basically creation, deletion, and update. You saw me use create and delete quite a bit. You saw me write match queries. You saw a basic query on uh, getting information. So now if we do a match A, C, B, and please notice that this is a graphical language. This parentheses represents nodes. Um, the edge with the label on it is in the property graph is a dash followed by an open left brace followed by the metadata and or property name followed by the arrow. All right. So this is all syntax that needs to be used. See, and you could see here in the graph that we have our graph database here. Now, I haven't added any weights. I haven't added anything like that. We can add, obviously, that in many respects if we want to. Um, but this is just a simple way of kind of modeling that information. Are there questions? Okay, so let's talk about how we might be able to leverage this inside Common Lisp. How can we model this in Common Lisp? Okay, so we're going to do the same kind of situation. We're going to create 2 nodes. Um, we could create, yes, for example, the example that I'm coming up with. So there's a question about, am I building a movie trivia database? Yes, I am basically following and trying to remodel the movie trivia database, the movie database that's already provided for you inside of the um, the Neo4j kind of like tutorial, but I'm doing it from scratch. So for the purposes of not just for you to interact with Cypher itself, but also so that you can, do like if you're just trying to learn Cypher and learn Common Lisp's abilities to do Cypher, you can certainly just insert the movie graph database that's currently available in one of the tutorial databases that Neo4j community provides you, and you can use that to kind of, uh, play around with Cypher itself. For the purposes of this discussion, I'm using that as a basis to try and test our Common Lisp API that we're kind of building on top of the new transaction API that's available for you. And obviously with that, there's a couple of things that need to be added into that API because for folks, for new folks who just came in and kind of are following our series, that API, that Common Lisp library that's available on Quick Lisp, is written against an older RESTful API that's only available up until version 3.5. So if you want to go ahead and use cl-neo4j today without any adjustments and just to learn Cypher straight up, you could certainly do so with its lisp-ier library equivalent inside um, Neo4j 3.5, but bear in mind that API has changed from 3.5 to 4x if you're using the RESTful side of things. Bolt, for folks who know about the Bolt protocol and Neo4j's drivers that are available, Bolt is a very different protocol. There isn't currently Bolt support in Common Lisp. That's something that we may address as part of the study group just so that we can understand what the Bolt protocol represents. But I thought it would be first more important for us to learn the graph database and then move on from there. Other questions? So I'm uh, so the question is about learning about what's the purpose of learning some of these tools. Yes, so there I do have some projects in mind to use Neo4j. One of my interests in Neo4j was essentially trying to see if I could leverage it inside of um, some some side projects that I'm working on. And I wanted to use Common Lisp for them, particularly the ability to do um, some AI related work inside the graph database that because the model and the problem itself was better modeled inside of a graph rather than like a relational database. And because I've been looking at graph databases from the RDF side of things, the semantic web side of things, and I've thought it would be a good excuse to actually go and play around with them, the graph and Neo4j itself, since it's been a while since I touched it. Right. So there was a comment about our use of movies for the sake of this example. And yes, we can create multiple multi-layer graphs on this. It one of the beauties of graphs is it's topological, right? To not put a pun on it, but yes, it's topological. It creates a topology that has different layers of different graphs, and you can always go up and up and up. You know, Much like Common Lisp, you can go full meta inside of a graph. And since our world is better modeled inside of a complex graph, it kind of fits this framework. All right, let's switch back to Lisp and see how we can do this, shall we? All right, let's go to our REPL. And again, for folks who are following along, feel free to stop me, ask questions. And we have someone in the peanut gallery giving me a comment about uh, this being like Wolfram's recent work in Wolfram physics. All right.
No, it's. I think it's true. You should watch some of his videos, and he's using basically graphs to derive a lot of things in physics. Now, maybe the derivation is not the proper way to derive these things, but they're getting a lot done. It's pretty interesting. So,
Well, okay. I will. I appreciate the clarification on that, just because I thought that was just an off comment. I was just like, okay.
you know me.
All right. All right. Okay, let's get back to our regularly scheduled program. All right. So, as we saw here inside our API, we're going to create at least a couple things related to relationships and um, for creation and deletion. Okay. Now, from what we saw earlier, with the new model, that means that we're essentially modeling these as merge queries. Okay, so ideally, you'd want to provide metadata information for this. So the API that was previously done, just to kind of show you what's in cl-neo4j and what we may need to end up having to accomplish a little bit more, is probably going to be slightly different. So let's first see what the first API did with the older Neo4 cl-neo4j. All right. And again, for folks and particularly the author of cl-neo4j, I will write this up as a proposal. Okay. Um, Maybe even a proper pull request. I need to still do a little bit more refactoring on some of this stuff just because I need to separate out your old API from the utilities and base data structures, and then I would uh, be able to properly test the newer API and be able to give you a proper pull request. Um, Call me a perfectionist, whatever, but need to get something fundamentally working with the appropriate reuse from what you've currently built on. So in requests, I believe it was requests, right? No, sorry, not requests. I keep thinking requests, but it's really REST API. We have this function called relationship create. Let me close this out. Relationship create, right? Or create relationship. Okay. And we see that in this node here, it took the RESTful API from node relationship to relationship type and properties to be able to create the new relationship. All right. So it takes the source node, the end node, the relationship type, which acted in is what they would call the relationship type. Okay. I'm not quite sure why the colon keyword inside CYPHER represents relationship types specifically, but I guess it's kind of the same thing with the node type. So for folks who are creating, let's say, simple analogy here, like ontologies. Okay, an ontology is basically a relationship from some generalized object to some more specific objects. You could think of this kind of way of modeling things like, say, uh, a, a taxonomical classification for animals. Okay, this is kind of the trivial canonical example. Like if you're modeling living things, you can have an ontology to actually do that kind of modeling. In that situation, the in the property graph representation, the colon whatever name in the node represents the ontological type. Um, and the node itself is going to have some sort of label on top of it too, and that more specific label and general label, that also is kind of a relationship type, and that also has a kind of a topological ontological representation to it as well in and of itself. That's why relationships also have a type on them inside um, Neo4j. And for consistency, they said that all these, after the colon, if you put some name on it, it's going to be representing the type. So that's what we're going to kind of merge onto here. We're essentially going to end up implementing these three new um, things, and we may end up also adding. We'll see if we can add additional functions for node properties and things like this, just because again, when you are as you are modeling your graph, nodes will get more metadata information, relationships will get more metadata information, and you want to be able to have the appropriate Lisp APIs to accommodate for those. And as you saw with the old API itself, it was already available to us as part of the RESTful API, and we need to kind of model the same sort of things inside of our newer transaction-based API, while leveraging some of the older stuff that was provided there. Give me just 1 second here. For some reason. Okay. Excuse me. Sorry, I had to take a little bit of water break. All right. So let's go to our transaction base. Okay. Let's first create a couple of helper functions here. And again, a lot of this is going to be based on the tx commit stuff that we're seeing here. You've already seen this kind of design here, and we could certainly actually we'll see some duplication for the time being, that we're going to at some point refactor into a macro, just to make things a little easier for us. But I wanted to first show you the process, as we are building our API, when it becomes appropriate to start using macros. Because sometimes some folks end up starting from the get-go about macros, just macros that, and you have to know when it will become important to actually start moving it over. If you know you're going to design, for example, your functions in such a way that um, you'll end up having a class of functions that all are going to behave kind of the same way with some additional behavioral changes. Sort of think of higher order functions. It might be more appropriate for you to end up making those into higher order functions. But if you're saying trying to create a data abstraction, okay, like think def class, but you're trying to create a set of APIs that are very common on there it might be more appropriate for you to create, say, a macro. Or in this case here, if you're trying to leverage several APIs together and you're trying to make it so that you can hide behind the fact that, okay, what we're ultimately doing is actually just defining a function that behind the scenes will pick the appropriate protocol or appropriate approach to actually send the request through this set of APIs that we're actually trying to integrate together. Then a macro also becomes very, very useful, because what you're doing is you're creating a common syntactic abstraction that is necessary for you to leverage and take against, and you're trying not to incur any sort of functional overhead, because a function call is there is some overhead in terms of creating the stack frame and then setting up everything to be copied appropriately, passed over the wire. And sometimes it's necessary for you to just go ahead and reduce that to just simply a syntactic level call or invocation to allow it to then inline all that information into a single function call. So to the end user of your API, it looks like you are giving them a function, but really what it's actually doing is generating some code for them. All right. This is kind of the stuff as you start learning Common Lisp a little bit more and more. And this is something that I've picked up through my 4 or 5 years of doing the series, that there is kind of an instinct that they're going to start getting to allow you to um, determine when a macro is more important versus, say, a higher order function. Now, if there are folks out there that are going to tell you that try to favor high order functions, but there's a time and a place for higher order functions, all right? And you must know when to use them. All right. You'll start getting this instinct as you start leveraging them, but there are sometimes cases where a macro is actually what you want. So let's go ahead and define our function here. Tx, let's say relationship create, I guess is what it is. And then what we need to do is, actually, we need to probably first do, oops, let me first create tx get node, and let's provide the ability for them to provide potentially node properties, right? Um, if we do get node by ID, I don't think we can actually necessarily call out to get node by ID because we're going to be leveraging CYPHER, and CYPHER, actually maybe, let me check something here. Okay, yeah, we won't be able to actually necessarily query specifically in CYPHER specific node IDs. Ah, there it is. Ah, okay. All right. So there's a couple of ways of doing this. Let's say that we want to do get node by ID. Okay. So let's do this. Hold on. This. Go back to package. Is there a get node by ID? Okay. So get node here originally is. Okay, it's using node ID. So this is, we're going to model exactly this one for the sake of our example. Okay. Let's go and do this. Get node ID. Okay. Now, in order for us to do this, we're going to create exactly the a match query for getting this particular node. Okay. Now, I know this might be overkill. It might be more important to inline it. I just like some of these helper functions just so that it's a little bit easier for me to like uh, figure out ways of potentially actually generating what I would think would be more important, more useful, which is maybe even this is where DSLs might become important. Like at some point, we might want to take these set of functions and actually create a Lisp to Cypher kind of compiler, um, kind of like think like LINQ in C sharp, for folks who are looking at this from that standpoint. Um, but for now, I'm going to write these as functions that will automatically do a syntax directed translation. So when you invoke the function, it'll end up generating you the Cypher query just for simplicity's sake. Um, get node by ID query. Let's do that, and let's do format nil match a where ID a equals that. That's it. And we can obviously even add, say, REST node properties. But for now, we're not going to add that for the sake of simplicity. Okay, we have that. Now we just need to go ahead and add inside here. It's going to be a get. Actually, I don't think it's going to be a get. It's going to be a post, I believe. I have to actually, because everything inside of this transaction commit is going to be a post, which is rather unfortunate. But for the sake of our then our URI spec is still transaction/commit because of the fact that we are doing this in a ad hoc transaction. Let's do encode, and we're going to make a CYPHER transaction because this is part of. And you could probably immediately see for folks who are watching this that obviously I could totally end up leveraging some macro magic to actually get this kind of all situated, because there's a lot of duplication here for this example. But again, like I said, I'm not going to do that for simplicity's sake, and we can then refactor it as we go along. And then just to illustrate our interactions as we were building out this API. Okay, so we now have our encode. Oh, we need to also specify what type of encoding we're actually doing. Oops. We need to say string, because then what's the other thing we need to do? Oh, status handlers. We need to add the status handlers, and like before, unfortunately, we need to go ahead and use uninterned symbols, because the macro expansion of this is not going to work otherwise. It won't decode Neo4 JSON output. I was thinking at some point that I may need to actually go ahead and make these into expose symbols, but I don't think that should be required, just because, as we saw last time, when you do a macro expansion on this, internally a lot of the uninterned symbols are getting called correctly by the macro expansion, and for whatever reason, for lambda functions, it's not actually doing that, and I'm not entirely sure why. When it's generating the lambda function, why it's not doing that. I would have to go and see how the macro is written to see why in some cases it's doing one thing and in some cases it's doing another. And we could take a look at that after our discussion today. So let's go ahead and get this, print this out, delete that, and we have our macro expansion. And what is it complaining about? File style or undefined variable URI. Um, why was this not showing up last time? Oh, Okay, this should work now. And hold on, let's go and take a look at this guy. It looks like I'm going to have to also add that here. Okay, this is now compiled. We're getting some style warnings, but that's mainly, again, related to the fact that I'm using uninterned symbols. And for folks just new to Common Lisp, just a quick review, anything that has a colon on it after is an exported symbol. That is defined inside a package that you've defined in def package, all right, as illustrated by package.lisp. All right, this each one of these um, hashtag colon um, symbols are a symbol that's part of the package that's going to be a member of the exported API as part of the def package. Okay. The reason why you do hashtag colon is because inside Common Lisp, that means that we want you to load this into the image as an uninterned symbol, all right, rather than an intern symbol. So the difference is an intern symbol, all right, is something that could be just used as is. So if you intern the word JSON in your Common Lisp image, NDCL user package, which is what normally users are started out into inside of a Lisp session. Okay, then um, JSON will end up getting essentially loaded into what's called a read table. All right, it has an intern symbol. All right, it will throw up an error saying that it's not defined unless you define it using either def parameter, def var, or a setf expander, what have you. But as soon as it gets interned using uh, one of those three approaches, each time you references that symbol is now interned into the package. Okay, it's available as part of the package as a first class citizen. When you do this hashtag colon, when you do a def package, when you load the package, now when you look at what we had before, sorry, the colon now makes the representative, the package name colon becomes your prefix, saying that I want to get something from this package. And then whatever you provided as part of the export and the public API will become um, available. Those are interned package symbols. All right. Those are package symbols that are interned when you loaded up the package and you're referencing it via the package. Okay. So unless you say use package, those aren't actually going to be uh, uh, directly accessible, those APIs. Okay. This is the difference between, this is the same equivalent to folks. Yes. So there's a comment about that. It makes the name available with the package name as a prefix. Yes, that is correct. It's the equivalent between doing an import in Python versus saying from Python use, all right, or from Python import, from Python package import this particular symbol. All right. So if you just say import OS, you have to always prefix everything with OS. But you say from OS import star, then anything that you imported from OS is directly accessible. All right. In Common Lisp, the equivalents are basically um, use package, def package, and then when you're using inside of a def package, you're going to be able to access it inside of the public API. I hope that makes sense for folks who are looking at this. The colon is basically everything that's part of the package that is not interned. All right. If you Those are basically symbols that are inside of the package that are technically accessible to you, but you shouldn't technically use them because the author explicitly did not expose them for a reason. They may change, they may get removed, whatever. All right. But they're technically still there because in Lisp, a running image is contains everything that the package loads into memory. So you still have direct access to those, and you can introspect and grab them. It's just bad practice. That's why I keep saying that colon is bad. You don't want to use colon unless in some cases it's possible. in some cases it's necessary. In this case, which we're using. All right, let's test this guy. We have our node. Okay, there's a question. So in line 28, yes, line 28, this guy right here is bad practice, but is necessary because the macro itself is giving us some trouble. So we need to fix the macro in order to correct this. If we correct the macro, we could fix this. I haven't had a chance to correct the macro. We might take a look into there and see how to correct it and how to fix it, so that this way we don't need to show up this stuff like we need to all the other stuff. All right. And line 37 is also bad practice. Both of them kind of are following the same kind of pattern. All right. Okay. Let's see if this works. We got our tx node, tx get node. Let's say we're going to get our can read node. Let's see what happens. Odd number of key arguments. Hold on. One. What are you talking about? Oh, I forgot to say return a here. Okay. You know what? Since we use a lot here, I'm going to use x just to make this, because in common Lisp tilde a means you're grabbing something from the in the format string from something else. So this might be more clear for folks. It's definitely clear for me. All right, let's try this again. And hold on, set f drachma header stream standard output, so I can actually see what our request is. Odd number of key arguments. What are you talking about? Hold on. Let me go back to this and see what it's mentioning. Um, key, but there isn't any keywords. Oh, this generates a key, right? Yeah. My apologies. I have to do this. I gotta get node ID 4. There we go. And we could see that our generated stuff is giving me a feature deprecated warning. We have road metadata code neo client notification statement feature deprecated warning. This feature is deprecated and will be removed. The query used the deprecated function ID. Okay, so even though it looks like they're trying to remove the ID itself, which is rather unfortunate, but okay. I will go ahead and change this up a little bit because they're trying to hide this. I'm wondering what is now best practice for getting cl-neo4j node by ID transaction API deprecation. Ah, okay. Apparently they replaced this with element ID. Okay. Let's see what this is. Use element ID instead. It returns a node or relationship unique identifier. Unique within that specific transaction. Okay, so let's try that. No, not that. Element ID. G. This is rather unfortunate. Okay. Apparently, this is giving me only. It's not giving me the specific. It's giving me an extended ID. I can't actually. Okay. 1 second. I may need to correct something here. Match where element ID A contains or no equals. Yeah, that's the problem. The problem is element ID isn't giving me all the information. Well, it's giving me too much information. See if I could do. See what. Let me see what it returns. Return element ID A. Yeah, it's giving me way too much information. So what I would have to do is I would have to still do a more generic one. Okay, it's rather unfortunate, but okay, we're gonna have to write the generic version of this. Okay, let's do this. We're gonna write two versions of this. This one, unfortunately, I cannot do, just mainly because of the fact that element ID is now providing you the full UUID of the actual node, which is good. I mean, it's giving you the full identifier of the particular node inside of the database, but for most people, it's not going to be useful. Um, and keeping that information might be necessary for some queries, but not in the case of this. I mean, we would have to we would want to retrieve that first, and then use that as a way to um, get the query. So um, yeah, so this may not necessarily be the way we'll do this. We'll come back to how to leverage this ID information just later on, just because like this here, um, because it simplifies things. It does sorry, it does change 1 second. Hmm? Oh, RX. There we go. While it does give us the exact node and the exact metadata associated with that node, really what you can see here, element ID is right now a significant large representation that we would have to somehow keep track of. Okay, so let us move on. Let us go to writing some quick things here for deletes. Let's just go ahead and write the same thing for delete with ID for the time being, and then later on we can always go back and change this to have some more generalized versions of this. Um, Again, I'm just writing out the quick stuff just so that we can just get through some of these more unique queries and get some more interesting stuff going into um, stuff in our next time, where we can actually start taking a set of data sources, ingest it into Neo4j, and then start actually writing some basic test applications, either for the command line or for the web. This is all infrastructure stuff for folks who are following along. Just necessary things that you need to kind of keep track of when you're starting to build up libraries. Um, so delete node query, node ID. The only difference between this one and the previous one is that, and go ahead and do this. Everything's done here, and we now have our delete query, although this is not going to work because we didn't write a detached delete, which is something I'm going to be talking about in a second. Okay. So why did this not work? So in CYPHER, if you have nodes that contain um, relationships, so you have an existing node that's nodes attached to several relationships, you must actually tell CYPHER, and specifically in CYPHER, you must tell Neo4j that the particular query node that you're trying to delete, all of its relationships must be removed. Now, this sounds very familiar to most people coming from the relational world, because this is a node with relationships is kind of like a foreign key constraint. So if the foreign key is available, you must actually do a drop in order for all the relationships associated with that get subsequently deleted to as well, because they no longer are valid once the node gets removed, right? So this is something we can go ahead and update. We can do a detached delete, and then this should actually go ahead and fix this problem. So let's go ahead and try and change this to use a detach delete. Detach delete. Let's see if that works. And yeah, it worked. And we could see this if we do this. Let me go back to our Neo4j screen. If we go to now and say match A, return A, you can see that the only node that's showing up is the matrix. Okay. And it's because of the fact that we went ahead and we told the Neo4j database that we no longer require you to maintain this node or of its relationships. Okay. As you start getting into Neo4j and start writing some of these stuff, you'll end up leveraging some of these things. There's additional stuff that I haven't talked about that it becomes important, especially when it comes to uh, queries and things like this. But I am so things like create query and so forth. But I went ahead and uh, I I'm going to go ahead and postpone that when we start writing applications because that's where some of that stuff becomes very useful. Okay, so we now have our node create, get, and stuff all set up using the older API for using ID. Again, I'm going to postpone actually doing some of the stuff related to the generic version just because it's just an extension of what we just seen here to make things kind of a little bit more flexible. And I'm going to go ahead and write something else here. I'm going to go and let's go ahead and write up our relationship create. Okay, so it looks like our API or exposed API isn't actually showing up here. Let me go ahead and restart my REPL. Restart my REPL. Okay. 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 And quick load. Neo4j. This should all work the way we are expecting now. Does not designate any package. Oh, sorry. This has some of my that's some of my refactoring stuff that I started earlier that I forgot to comment out before our stream. So my apologies. Okay, go ahead and very quickly add the relationship stuff here. We have that. Okay, so we are going to get these three now that we're going to do. All right. Transaction for J, def neo4j tx relationship create. And let's go ahead and model this the same way that the previous one has. Again, this is all slightly essentially reducing the number of abstractions that are being able, because before it was a RESTful API, so relationships were a resource. Now we're actually going to have a separate thing for actually dealing with what's it? It's now leveraging transactions to actually go ahead and leverage that. So the endpoint is going to be one. It's TX. Okay, whenever you're dealing with committing a transaction, creating a transaction, and so forth. And all the ad hoc queries will go through that endpoint. Essentially, is what this current example is about. Let's go ahead and do that. Create relationship. Okay. Source node, destination node, because that's how I would prefer to call this. We're going to call it relationship type, and then the properties on the relationship type. Okay. Now, as with all the ones that I have written, I've actually modeled these after these template queries that we create. We're going to go ahead and create a relationship query. This is going to take in the several nodes. Now, in order for this to this particular thing to work, we're going to end up probably having to write a little bit more of a complicated query. Okay, one specifically for the getting of the node, the source node and destination node from within the match query, rather than actually having it internally uh, grab it as two separate nodes, because beforehand we were able to grab the nodes through get node itself, but we haven't written a deserializer to take the output from the get node by ID to give us exactly that specific node object. And when we do that, then this becomes a little bit easier. But I'm gonna postpone that to next time, just because it's going to take a little bit more work to actually do it, and we're kind of running out of time. My apologies that all this explanation was taking on. But again, feel free to stop me if there are any questions. I'm all available for doing this. I'm just going to try and see if I can finish this one last thing up before I open the floor to additional comments and discussions. Okay. Okay, let's see. Format to nil. Match A. Tilde A colon A. And let's see if, and do this. Tilde A colon, then do that, tilde A, tilde got. For folks looking at this, I'm wondering what the heck am I writing? Just a quick review. This is a way for the format string to go and iterate a collection of key value pairs coming from an associative list or any sort of collection. If this looks a little confusing to you, I recommend you review Practical Common Lisp, which is available by GigaMonkeys on his website. It actually is probably the best book on introducing you to Common Lisp and the syntax, and it's one of the best introductory books I've read on the language, and honestly, it also provides a really good explanation of format. I'm posting it on both the chat and the live stream chat too as well. Okay, so this is going to do that for our source. We're going to go ahead and correct this also for our destination. we need to do match for our destination. Tilde A. Actually, we could just go ahead and do this. Yoink. Boom. Okay. Now we need to actually do, oh, my apologies. If we are allowing you to do this, we better make sure that source and destination don't get mixed, but that's fine. We could go ahead and deal with that later on. Merge, and then we add essentially tilde A, which is our reference for the first part. And we're only going to do the forward relationship. So from source to destination, we're not doing bidirectional. All right. We could certainly add that too as well. It can go in any direction. But for the sake of simplicity, I'm going to stick with just the forward. A, arrow, tilde A, and then semicolon, and now we need to fill this stuff out. So in here, we need to say this is going to be our source node, and we better also put source node properties here because we need those for restricting what nodes we're actually adding this relationships to. Source node props, destination node, no, DST node props, and then relationship type, and it has its own properties. So we need to also write that in here. Again, using the same sort of syntax that we saw earlier. And, oh, wait, I forgot something. Yeah, I forgot to add brace here, oops, there. And we need to add inside here this. Okay. And properties. All right, this is all written, and what is the error? Too few arguments. Okay, hold on. Let me just make sure. I must have done something wrong here. One. Okay, so source node. Oh, dummy. We do not need this. Got to subtract 2 of these. We could change that, but where I would have to add like the, actually, hold on. No, you know what? I'm going to go ahead and add that. I'm going to do this. I'm going to add source node type as well, and destination node type. So this is just as general as it can be, essentially. And obviously this here, these three, when you see this kind of duplication, if you notice, we can refactor this and make this into single objects that we can pass in as a single thing. It's not that big of a deal. I'm just doing this for sake of example. Boom. Right? Mm, warning, too few arguments. Hold on. What did I miss? Um, got it. Got it. It's because of these two here. I can't do that. Okay. I'm going to do this. X, Y, where, where. So I'm going to just do this to make this easier for us. Match X where X, shoot, this is going to take a little bit more of a thinking, shouldn't it? Because what the problem is basically I tried to create a generalized match for creating this relationship node, right? But we don't know how many properties people are going to end up passing in. We don't know how many nodes, node names people are going to pass in, right, and so forth. Obviously, for the sake, we need to get this information for two nodes, all right? Um, so there's two ways of doing this. Either I write everything inside of the individual nodes themselves and label them X and Y, and only allow them to query based on uh, uh, based on node properties. Okay. Or I would also have to add some way of creating the type. Say, okay, we're only going to do X colon tilde A, which is the source node type. And then source node, the where clause will actually deal with the individual properties themselves. That's another way of doing it, to restrict what nodes are actually going to get the relationships, because this is where it becomes very, very important. If you're trying to only do one single node, you need to be able to constrain the query to whittle it down to a particular node, and this is where it's currently somewhat of an issue. But yeah, this is going to require a little bit of forethought. I thought I would be able to do this quickly live, but it looks like I'm going to have to think about how the query should be structured correctly. So um, we ran out of time, unfortunately, for me to write this query, but as a review, today we covered kind of the basics of Cypher. We covered how to create, delete, add nodes, run merge queries inside Cypher. We learned how to actually add inside a, the our common Lisp library an additional API for getting nodes by their ID. We also introduced element ID, which has been introduced as part of the updated API for Neo4j in order for folks to actually uh, get specific IDs for specific node objects. But has we've encountered element ID is not the same as ID. ID returns an integer representing kind of like the row number inside of whatever node database, the way nodes are being stored inside Neo4j. Instead, it's actually returning a string that contains the graph database number, unique identifier, UUID, and particularly the local ID for inserting into the database for that specific node. So this information may be useful for some cases for uniquely identify a particular node object. We're going to probably have to establish that next time to actually create these kinds of queries. Um, and next week, hopefully, we could finish off writing out the necessary functions that we need to work against the newer Neo4j database for us to actually then start writing some basic applications on top of it. Um, I will leave the floor to questions and comments, and any additional Common Lisp related questions, uh, so that you can continue probably experimenting in your free time. In the meantime, I'll go ahead and adjust the query stuff that I need to do for that in the time being. So, any questions? Hmm. Well, thanks everybody for joining us. Um, it was a lot of fun today to see this kind of coming together. Um, and I hope next time we have even some more great fun experimenting with this graph database and Common Lisp API. Thanks.